Ready-made maths YouTube mathematics training videos. Teacher and teaching assistant training in all elements of mathematics. This week we are now going to be looking at mental multiplication strategies. This is kind of a continuation from the first 2 weeks when we looked at mental addition strategies. We are now going to look at a whole range, a whole repertoire of mental multiplication strategies as well. These videos are more intended for Key Stage 2, as the majority of strategies require children to already have a bank of tables, facts, and then start to develop a range of different approaches to be able to multiply mentally. This day, day one, we're going to look at an introduction to all of the strategies. As with mental addition, the principles are the same. First of all, when I'm thinking about a calculation, can I make it or can I draw it is where I'm going to start with my understanding, and as it becomes a mental skill, I say to myself, can I do it in my head? If the answer is yes, then straight away I can write the answer down. With mental multiplication, more often than not, it may require a jotting to support the understanding as well. So in these sessions, we're going to be looking at, can I do it in my head? And can I support that with a jotting? So hopefully, by the time we've finished the 7 or 8 days of training that are going to go together towards mental multiplication, we'll have a large range of strategies that we can use so that whenever we're given a kind of single digit by 2 digit multiplication or a 2 by 2 digit, we can look at it and make a sensible decision. Can I do it in my head? Do I need a jotting? Can I make the calculation simpler and get the answer quicker than just relying on a column method? Good morning and welcome to the start of a new section in the Ready-Made Maths training videos. Earlier this week we've been looking at place value. What we're doing now is we're moving on to a whole series of shorter sessions on mental multiplication. Now if we think back to the first 2 weeks of the Ready-Made Maths YouTube training videos, what we looked at in the first 2 weeks was a whole series of sessions on mental addition. We looked at MC, wrapper, code and number. We introduced each of those strategies: round and adjust, number bonds, double and adjust, counting on, partitioning, and then manipulating the calculation. And then we drew them all together and had a whole week of activities on games and lots of different ways to practice using a really good range and a big repertoire of mental calculation for addition. Since then, quite a few people have asked whether I'll be doing the same thing for any of the other operations. And the one that seems obviously most likely to have an impact would be multiplication. There's a lot of strategies for mental multiplication. They're mainly applicable for years 4, 5 and 6, but certain ones can obviously be used earlier. And they all, in the same way as everything else, can start off with a visual. We are going to have slightly shorter sessions because with the addition ones, obviously we had a lot of resources and a lot of apparatus to back up mental addition, because a lot of it was 2-digit numbers and 3-digit numbers. Now obviously for multiplication there won't be quite as many visuals and quite as many images, so the sessions will be a little bit shorter. But hopefully again at the end of around about 6 or 7 sessions, I hope what you'll have is a bank this time of mental calculation strategies for multiplication. Once we've got those, again, whenever you're given a relatively simple multiplication, hopefully you'll look at it and think, can I do it in my head? Rather than always turning to pencil and paper as we so often do. Now, the first thing that I just want to kind of cover before we move into the actual activities and the overview is tables facts. When we did the number bond session for wrapper, code and number, we had a session on using number bonds, and then the following week I did a training session for a day on learning number bonds. Now, obviously, in order to do mental multiplication, the most important thing we need to have is a bank of tables facts. We need to know our tables. We need to have those almost straight to hand, those instant recall facts that children really need. Now at the moment I'm not going to put that as part of this training package, because this obviously at the moment is about the actual strategies. So I'm going to assume to begin with that the children who are taking part in these activities have already got quite a few mental multiplication recall facts at their disposal. Obviously in future training we can move into loads and loads. I've got days worth of stuff on how to learn tables facts. But what I want to do, as I say, for these is just to focus this time on the strategies, almost assuming that the basic facts are already there. So if we imagine really that we've got from 1 times 1 to 12 times 12 relatively well secure, and again we'll see them and practice them over the course of these sessions as well. It's not the usual array of different resources, but just a whole series of calculations that actually on the surface look quite complicated. So let's look down at the table and see what we've got here.
And you should see 9 boards, each with a multiplication tables challenge. Before I go over to the main board and we discuss the different strategies we could use in order to solve them, these are basically all of the different types of calculations that we'll be looking at over the 7 or 8 sessions that we'll be doing for mental multiplication. So many of them can be answered in more than one way, but we're going to choose a certain strategy for each one. I've kind of looked in the top corner and written something. Don't worry, that won't mean anything at the moment, but we're going to be using a little strategy for each of those. But all I'd like you to do is going to pause the video, have a look at them, and just, are there any of them that you could do in your head, or with a very quick jotting? Are there some of them that you look at and think, no chance whatsoever, without a written method? And are there others that you think, you know, I'm almost there, but I could just do with it, you know, a little bit more writing down. So which can you do straight away really quickly? Which will need a little bit of a jotting or a little bit of help? And which of them will definitely require a written method? Now, on a first cursory glance, I think the 3 which kind of jump out as probably being a little bit easier to do are the 3 that just involve multiplying by a single digit. Looking at this one, 86 multiplied by 5, I think once you know your tables facts and you've started to work on multiples of 10, we know 5 times 8 is 40, so 5 times 80 is 400. We know 5 times 6 is 30, so that one is quite easy as you know, as a partition. 5 times 80 and 5 times 6. Similarly, I think that's probably the easiest one to do as a mental arithmetic one. 3 20s are 60, 3 7s are 21, add them together, we get 81. And that one does actually have the PA for partition written next to it. At the top left, we've got 26 multiplied by 8. Again, we could do it as long as we know our tables, and we can jot things down as well as a partition. 8 times 20 is 160. 8 times 6 is 48, and 160 add 48 is 208. Not particularly easy, but with a jotting, again, we can probably do that one as a mental arithmetic strategy. The others look on the surface a lot more complicated. So what we're going to do now is we're going to move over to the whiteboard. We're going to take each of those. I'm just going to show you a quick strategy that will work for each of them, and as a kind of overview of what we're going to be doing over the next few sessions. Now, you may recognise from the mental addition session, if you have watched any of those, the mnemonic MC Rapper Coda Number. You'll be very pleased to hear I'm not going to be dressing up as a maths rapper as I did in the addition sessions, but the same little letters still apply. MC, manipulate the calculation. Ra, round and adjust. Pa, partition. Co, count on. Da, double and adjust. And number, number bonds. There were the addition. Now, when it comes to multiplication, some of those are going to change. On the right-hand side, I've written a calculation next to each of the little sections, and we're going to talk about those in a second. But we're going to look at which ones are still going to be there as mental multiplication strategies. So I'm going to come back over to the board now, and I'm going to change certain ones. What you should see now is that MC is still here, Ra is still here, and Pa is still here. So MC Rapper are the same strategies as before. We can still manipulate the calculation, we can still round and adjust, we can still partition. The other ones have changed. Rather than code a number, co has become fa, do has become do, and number has become rio. So our new rapper is MC Rapper Fa Do Rio. You don't need to remember that. It's just a way of actually, you know, just putting the strategies up. But these are the strategies that we're going to be looking at over the next 6 or 7 sessions. Manipulate the calculation, round and adjust, partition as before, factorising, really good, doubling up rather than double and adjust, and reordering rather than number bonds. What you will see is that doubling up is similar to double and adjust, and reordering is actually the multiplication version of number bonds. So we'll see how they work as well. So what we're going to do now is I'm going to take each of those just very quickly in turn. I'm going to run you through the quick fire mental strategy for each one, and then over the next 6 or 7 sessions, we'll take each of those in turn and practice them. I'm not going to take them in that particular order. I'm going to move around the orders as before, but I'm going to take you through each of those individual strategies.
When we looked at mental addition, as we've just seen in the classroom, we looked at MC Rapper Coda Number, where I came dressed as a maths rapper and took you through the first 6 strategies that we learned. If you've not had a chance to look at the addition strategies, it's well worth going back and looking at the 10 videos that make up the first 2 weeks of the Ready Made Maths YouTube training. You will see a whole range of ideas, activities, games, visuals, and key approaches to give a whole bank of mental addition strategies for children, but also for adults as well. So do take a look at those if you've not had a chance to look at them yet. Obviously, what we're now doing is moving on to mental multiplication. The slide you're looking at comes from the sense of number visual calculation policy for mental maths. There's a whole range of those for mental maths, for written maths, and for concrete. Again, if you've got working walls in class, have a look at those. They're on senseofnumber.co.uk and they can be adapted for every individual school. This is the set of strategies that we learned, MC Rappa Coda Numbo. As we move to multiplication, you'll notice there are actually, in the sense of number policy, 10 strategies. What I've tried to do to make life a little bit easier is try to link it a little bit to Rappa Coda Numbo, and I've kind of rearranged them slightly. You'll notice strategies 6, 7, and 8 on here are all linked to doubling. So I'm going to put those together just to call those the doubling strategies, and I'll cover all of those on the same day. The other ones I will be covering probably in one session, in one session each. So this is kind of my new variation where we've kept MC Rapper because they're the same strategies, manipulate the calculation, round and adjust and partition. And I've introduced, as I showed you in the classroom, the 3 new ones: Factorize, doubling strategies, and reordering. I'm constantly deciding whether to call this one do or do. Doubling strategies or double up. I think I'm going to stick now for the rest of the sessions with do, just because they're all doubling strategies. So MC, Rapper, Fado, Rio. There's also 2 bonus strategies at the end that we're going to cover in the final 2 days. They're separate ones that can just be taught as simple additional strategies.
So let's begin at the table. We might as well begin with the one that we've already done earlier, 27 multiplied by 3. That one is PA partition. We're going to have a whole session on different ways to develop the skill of partitioning using number cards, digit cards and dice. But very, very simply, 3 times 20 is 60, 3 times 7 is 21. We jot that one down, 60 add 21, 81. That's that one pretty much covered.
Looking at the sense of number visual calculation policy, you can see here a more expanded version of the strategy for partitioning, where you can visually see the 15 has been split into the 10s and the 1s, 10 and 5. We multiply both those parts by 5 and we get 50 and 25 gives a product overall of 75. The version we looked at in the classroom was a more simple jotting where you just draw quick lines. 20 times 3 is 60, 7 times 3 is 21, and add them together. It is probably the most common strategy, and we're going to be looking at that one over a full session very, very shortly.
Let's now move to the second single digit calculation, 86 times 5. The strategy I'm going to use, again, we could partition because it's quite an easy partition, but we're multiplying by 5. Something that's very useful to know about multiplying by 5 is that 5 is half of 10. Therefore, if we multiply by 10 and half it, we'll get the correct answer. So 86 times 10, 860, we half it, and the answer is 430. Another calculation that works in a very similar way is 48 multiplied by 50. This one we're not going to multiply by 10. What do we know about 50? We know that 50 is a half of 100. So let's do the easy calculation. 48 multiplied by 100, 4,800, and just half it. That gives us 2,400. So again, on the surface, it doesn't look too easy, but straight away we use what we know. That's half of 100, 4,800 or 4,800, half it, 2,400.
As we've just seen, multiplying by 5 or multiplying by 50 can be done as a simple partition, but can also be done this particular way. Multiply by 5, no, we'll multiply by 10 instead, and then we'll halve it. And again, we're going to have a range of approaches that you're going to see in a future session on developing that particular strategy. That's the version that we looked at, which was 48 multiplied by 50. Well, let's not do that. As you can see, and as we showed in the classroom, we multiply by 100 and then halve that answer to give an overall product of 2,400.
Let's now go to 26 multiplied by 8. Again, as we've said before, partitioning is the default strategy. It always is. Partitioning will always work, but 8 20s, 160, and 8 6s are 48. Add them together, 208. But this is DO, which means double. So we could actually use a doubling strategy for this. We could use 26 times 2 is 52. We double it again to get 104, and we double it again to get 208. So we can multiply by 8 by double, double, double. We can multiply by 4 by double, double. Obviously, we multiply by 2 just by doubling. So 26 times 2, 52. 26 times 4, 104. 26 times 8, 208. So again, we're going to have one session just looking at the different doubling strategies.
As we've just seen, doubling is great, and if you want some ideas and activities for doubling, please go back to the first week of training where we looked at double and adjust, and we talked about ways of learning doubles, of remembering doubles, recalling, doubles jottings, and that idea of making sure that doubles are a really important part of what we're doing within our mental and oral starters or just mental mathematics sessions. Once we know our doubles, then we can multiply by 8 by double, double, double. We can multiply by 4 by double, double. And if you want to even multiply by 16, 26 times 16 would be 416, because we can double, 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 double. So you can see how many ways that you can use that strategy as it develops.
Moving back down to the other tables calculation that involves doubling, this double up strategy. This time I've reorganised it to the left hand side of the board. 16 multiplied by 14. Now, I don't know the answer to that one quickly. I could double up, I suppose, from 2 times 16, sorry, 16 times 2, 16 times 4, and so on. I think there are 14 times 2, 14 times 4. That will take a long time. I think rather than do that, I want to use an associated fact. So I'm going to rewrite an associated fact up here. I'm going to write 8 times 7 there equals 56. Underneath it, I'm going to write 16 times 7, and then obviously we've got 16 times 14. Now, we'll look at this in a lot of detail with visual resources on the actual session, but just one of those nice little mental mathematics tricks that is worth knowing. If you get a calculation like 16 times 14, let's look at an associated fact, 8 times 7, because 8 is half of 16 and 7 is half of 14. So I'm going to start with the fact I know. 8 times 7 equals 56. All I need to do then is double up. If I double up 56, I get the answer 112. So I know if I double 8 to get 16, 16 times 7 must be 112. So I've taken one fact and doubled it, therefore the product doubles. Now what I've actually got to do is 16 times 14. So I now need to double the 7 to get 14. So if I double the product, again, I'm going to get the correct answer. Don't worry about that just being a little bit of a trick and a little bit confusing. We'll look at that in a lot of detail on that actual session. So how we start off with one fact and we keep doubling up until we get an associated fact.
Continuing with the doubling strategies, this one again in the classroom might have been a little bit more complicated to actually visualize. Again, what we're going to do in the future training session on that strategy is show the whole thing visually so you can see how it builds up. But it's a very simple principle. If you double one number within a calculation, a multiplication calculation, so I double one of the multipliers and the product also doubles. So 8 times 7 is 56. Therefore, another 8 times 7, i.e. 16 times 7, will give double the amount, or 112. The example we looked was a high-level version, which we will be moving towards in those future sessions. 16 multiplied by 14. This time, we doubled the 8 times 7 to get 16 times 7, and then we doubled the 7 to give us 16 multiplied by 14. Again, don't worry if that seemed a little bit quick, because we'll be going through all of that in the actual specific doubling training sessions.
What remains now on the table are probably the more complicated of the calculations that we've been looking at. I think what we'll take now is the one here, 198 multiplied by 6. And in the same way, it's an RA, round and adjust. We'd use that one in the same way that we rounded and adjusted for addition. If that was 198 add 674 or something, what we'd do is we'd add 200 and then we'd subtract 2. We just got to apply the same thing with multiplication. It's a little bit more complicated, but it's generally the same strategy. So I'm just going to rewrite that calculation. 198 as 200 subtract 2. I'm going to multiply all of that by 6. So 6 multiplied by 200 is 1,200. 6 multiplied by 2 is 12, and if I subtract 12, I get 1,188. So what we've basically done is we've imagined the 198 is 200, we've multiplied that by 6, that's the 1,200, but we've got an extra 2 to deal with. 6 times 2 is 12, we've got to subtract that because the answer is less than 1,200. Again, we'll be covering that in a lot of detail on the actual round and adjust day with much simpler calculations to begin with.
This is a slightly simplified version of what we've just seen in the classroom. It's still using the number 198, but this time multiplying by 4. The principles behind this are the same as with addition. 200 multiplied by 4 is much easier to do than 198. Let's not bother doing a column method for 198. Let's just do 200 times 4, but then we need to adjust because obviously we only need 198. So 198 is 2 less than 200. So obviously if we're doing 4 198s, we want to do 4 200s and then subtract 4 2s. So it's 800, subtract 8. Again, talking about it as a visual this way is a lot harder than actually visually seeing what that means. So again, we'll look at that practically and you'll be able to see in the round and adjust session exactly why that method works.
The next two are kind of variations on the same theme. We've got factorising and we've got manipulate the calculation. I'm going to start with factorising and then we'll move into manipulating. So I'm going to hold this one up. This is one of my favourite strategies because that looks quite hard. 36 multiplied by 25. It looks like a long multiplication. Now there are two ways to do that one. We could, if we wanted to, think about 25 as a quarter of 100, and we could multiply by 100 and halve it twice. That's one strategy. But the other one is to use the idea of factorising. Now factorising a number is obviously finding factors of that number. 2 factors of 36, well we could use 6 multiplied by 6. We could use 12 multiplied by 3, but what I'm going to go for is 9 multiplied by 4. So I'm going to rewrite that calculation underneath. I'm going to write 36 as 9 times 4, because 9 times 4 is 36, and then we're going to multiply that by 25. How does that make the calculation easier? Well, let's have a look at the numbers that we've got. We've got 25 multiplied by 4, which is 100. We multiply that by 9, and we get 900. So really simple, we've just made it easier by factorising. If we'd have done it a slightly different way, if we hadn't gone for, let's say 6 times 6, it wouldn't have been as easy, but we could have done 6 times 25 is 150, and then we'd have to do 150 times 6. Wouldn't have been quite as easy. So I think we chose the right version there with the 25, with the 4 and the 9. So 9 times 4 times 25. So that's the factorising strategy.
As I mentioned, I really like this strategy. This was the example we've just done. Every number that's a multiple of other numbers can be factorised. We looked at 36 as 9 multiplied by 4. And then we made the 25 multiplied by the 4 to give us the 100. So we simplified that one just by factorising the 36. We could potentially factorise the 25 as well. We could have made it 9 times 4 times 5 times 5. That would have given us a 4 times 5 in the middle is 20. 20 times 5 is 100, and multiplied by the 9 will give us 900. So there are various ways that we can do it. But factorising is a kind of unknown strategy, very rarely used, but can make a calculation a lot easier if you spot it.
Only 2 calculations left, and as I said, there'll be a session on each of these individually, so you'll have a chance to practice each of these different strategies. I'm going to take 12 multiplied by 15. The letters we've got there are MC, manipulate the calculation. As with addition, this is always my favourite strategy. I love the idea. It's very much a mastery strategy, very similar to what they would do in Singapore, which is to look at that and think, I don't like that calculation too much. There's probably quite an easy way to do that one because the numbers aren't too difficult. We could probably do 15 times 10 and 15 times 2 and add them together. So 150 and 30 is 180, or 12 times 10 is 120, and 12 times 5 is 60, and add them together to get 180. So it's not too difficult a calculation anyway, but there's actually a much easier way to do this. This is based on manipulating it and making another calculation that's worth the same amount. So rather than 12 times 15, what I'm going to do is I'm going to halve the 12, which gives me a 6, and I'm going to double the 15, which gives me a 30. All I've done is I've halved one number and double the other number. That always works for any multiplication. If you have one of the numbers and you double the other number, the product stays the same. We'll be proving that one in that particular session, and we're going to be looking at lots of ways to apply that strategy. But 6 3s are 18, so 6 times 30 is 180. So again, probably my favourite of all the strategies that we'll be doing.
We'll be spending quite a while on this one because there are many, many variations of manipulate the calculation, a little bit like they were for addition. The variation I've just shown you is basically make the calculation easier. And if you double a number, the product doubles. If you halve a number, the product halves. So if you halve one of the numbers and double the other number, then the product's going to stay the same. That's basically the principles behind it. Again, we'll explore that and we'll prove exactly why that works with mathematical apparatus in that particular session.
Our final strategy is Rio, and this is a new one. It's kind of the multiplication version of number bonds. With number bonds, we find numbers that go together in order to make a number bond. With Rio, we just reorder the calculation. Exactly like addition, multiplication is commutative. And there's so many children that face with that, and I've seen a lot of children in the past 12 months doing calculations like that, and I've set them, they look at it and go, oh, 8 times 9 is 72. Oh, 72 times 25, it's a long multiplication, and then they're down to pencil and paper. What we need to do is think, is there an easier way of doing it? All we do is we reorder the calculation. I'm going to start with the 25 first. I'm going to multiply that by 8. I'm going to multiply that by 9. Let's have a look how easy that's going to be. Well, first of all, I know that 4 25s are 100. Therefore, 8 25s must be 200. That leaves me with 200 times 9. 200 times 9, 1,800. So look how simply we've changed a complicated 72 times 25 into a much, much easier 200 multiplied by 9. Again, we're going to have some much easier versions of those that we're going to look at, and that's the first strategy that we're going to be doing tomorrow.
And we completed the calculations with this particular one, the reordering strategy. Again, lots of children do see this one, and they're used to manipulating multiplication into different orders. But for the ones that don't, you would end up with 8 times 9 is 72, 72 multiplied by 25. If you did put the 25 and the 9 first, you'd end up with a slightly more complicated 225 multiplied by 8. But if you spot the 25 can go with the 8, then we multiply those two first, we end up with that far, far simpler. 25 times 8 is 200. And 200 times 9 is 1,800 or 1,800. It's just a matter of having the idea of practicing that, so I know that I can always use that commutative rule for multiplication. That's the strategy that we're going to be focusing on and going into in detail tomorrow.
So thank you so much for joining me for the first of the mental multiplication videos. Don't worry at all if you found that was a little bit quick. You found some of the strategies a little bit complex. I just wanted to give you a general overview of the different types of strategies that we're going to be covering over the next few days. We will be taking each of those individually in different lengths of sessions. Some will be much shorter than others, and basically looking at how to develop children's mental arithmetic skills based on a bank of multiplication facts. So as I said, don't worry, we'll be taking all of those at a much simpler level and building them up. So some of the numbers that we just saw there won't come until towards the end of those strategies. What I wanted to do today was just kind of outline that if we do have a repertoire of strategies, then every time we see a calculation, we're thinking to ourselves, there must be an easier way of doing that. There's often an easier way rather than always having to rely on that long multiplication strategy. So please join me tomorrow when we're going to take the idea of reordering. We're going to get some dice, we're going to get some digit cards, we're going to get some, obviously, pencil and paper, and you're going to get the opportunity, like we did with mental addition, to pause that video regularly and have a little go yourself and try out all of the different strategies. So tomorrow is reordering. I look forward to seeing you then. Thank you very much.
So thank you so much for joining me for the introduction video to mental calculation in multiplication. Everything will be much clearer and it will be much more visual in the other sessions, but what I wanted was just to give you the opportunity to see the wide range of approaches that we're going to be looking at. Tomorrow we're going to be looking at reordering, which is less of a visual one, and then we're going to be moving into some of the others where I'm going to be getting base 10 apparatus and arrays and abacuses and showing where mental multiplication begins before then developing into the mental arithmetic strategies. So I hope you've enjoyed the first session, and I do look forward to seeing you all tomorrow for the first official strategy, reordering, or REO. Thanks a lot, and I'll see you tomorrow.